Tantor Audio, a division of Recorded Books, presents In Defense of Plants, an exploration into the wonder of plants, by Matt Candeias, Ph.D., narrated by Matthew Boston. Preface. Why In Defense of Plants? Plants don't really have a voice in today's busy world. In fact, most people I talk with think plants are boring. It is a sad reality that when most people step outdoors, at best, they see a static green wall. If they do notice plants at all, it is likely those that either cause them issue, for example, poison ivy in the hedge or a rebel dandelion on the lawn, or that they have some sort of use for example, lavender, corn, or bananas. Whether for economic gain or some purported medicinal benefit, we only seem to care what plants can do for humans. This is a travesty, because plants are incredible living organisms that conquered land long before any animal crawled out of the ocean. They are fighting for survival, just like any other form of life, and their sessile nature means that they are doing so in remarkable ways. If there is one thing that my efforts with the In Defense of Plants podcast has taught me, it's that even the slightest familiarity with plant biology, ecology, and evolution will demonstrate that plants are far more dynamic than any of our forebears could possibly have imagined. Sadly, these stories often go untold. Hop online or pick up a book, and you will find that a vast majority of popular plant literature focuses on two major areas of interest: folklore and herbalism. Imagine wanting to look up information on animals such as black bears or pangolins, but all you can find is how to cut them up, process their organs, and make tinctures or food with them. Any rational person would be outraged by this. These animals are so much more than just what their parts can supposedly do for us, and yet such tales are the standard for plants. It's almost as if interest in plants peaked in some bygone era, before we really understood what plants are about. Over the last century, science has revealed that plants aren't static backdrops to more charismatic life forms like birds or mammals. Plants are active players in the drama that is life. Even more, they are largely responsible for life as we know it. Every terrestrial biome on planet Earth begins with plants. Aquatic biomes aren't exempt either. Aside from deep-sea thermal vents, aquatic systems around the globe depend on photosynthesis, whether it be from algae, seagrass, countless species of phytoplankton, or plants washed into the water from the land. At the heart of all is photosynthesis. This wonderful biological Rube Goldberg allows plants to capture energy from our nearest star and use it to break apart water and CO2 gas to build complex organic molecules like sugars. Without photosynthesis, we would be living on a closed, finite planet. Hell, let's be honest. Without photosynthesis, we wouldn't be here at all. Our own story is tied to plants. Yet we treat them like inert tools. Some of them move at alarming speeds to capture animal prey, while others wage chemical warfare below ground, unbeknownst to most of us. My goal in writing this book is that I want you to see plants, even if for a moment, how I see plants. Maybe some of you will even be bitten by the botanical bug. Our planet certainly could benefit from more plant fanatics running around. What follows are stories about how plants have changed my perspective on the world. As you listen, I ask you to keep a couple things in mind. For one, at any point in this book, you might be thinking something to the effect of, "You forgot to mention this or that." Did I? Or perhaps, is that simply a tale for another time? In writing a book like this, one must always remember that there are endless examples and facts to draw on from nature. It is simultaneously fascinating and daunting. This book is not meant to be a complete story, nor is it entirely autobiographical. Instead, it is an ode to my journey and experiences thus far. The second is, while I strive for scientific accuracy in my communication constantly, this is not meant to be a textbook. A wise person once told me, I wish I could remember their name, that for science communication to be successful, the stories need room to breathe. As such, I take some liberties in my choice of words. I want to make it clear that I do not think plants are conscious in any way that we can comprehend. The rise in consciousness as a topic of discussion, I think, stems from a lack of imagination. Plants do not have brains. They do not have a nervous system. As far as we can tell, there is no central processing unit in plants. Plants operate largely through diffuse chemical signaling. And to think that any human possesses the capabilities to understand how a plant interacts with and perceives the world around it is to demonstrate a hubris that can only come from our narcissistic minds. I take some liberty in anthropomorphizing certain situations, purely because I think it helps the listener connect to plants a little bit easier. At no point should you interpret that in any way other than as a convenient metaphor. Finally, evolution does not have agency. It is not a hierarchical process. Evolution via natural selection works with what it has available to it, culling things that don't work and rewarding those that do by allowing them to live long enough to reproduce. Evolution is an unthinking and unfeeling force of nature, but that doesn't mean we have to talk about it in those ways. I would much rather someone walk away from this book, appreciating that evolution occurs and has shaped all life on this planet in remarkable ways, than bore the listener with hyper-specific jargon. If that bothers you, there are shelves of academic books waiting for you. What follows is a celebration of plants as the incredible organisms that they are. These chapters are filled with personal discovery and scientific wonder, and it is my hope that each of you comes away thinking about plants a little bit more in your daily life. I am here to defend plants. Chapter 1. A Rocky Start. How I Learned to Love Plants in the Bottom of a Quarry. I have a confession. I used to think plants were boring. I wasn't alone either. I know for a fact that this is an opinion shared by far too many people. That's not to say I didn't love nature. Far from it. I have always been a nature nut. But my early interest in the outdoors was consumed by things that could move, like insects, fish, lizards, and snakes. Fish were my first real obsession. My grandfather, who was an avid gardener, used to take me to a nearby creek that ran through town, and we would spend hours trying to catch minnows. Fish just seemed so otherworldly. They lived in a medium that I could not, and their entire anatomy was so different from what I was used to with my hands and legs. I loved the mystery that surrounded fish, and it never really left me. By the time I got to high school, my obsession with aquarium fish was in full swing. I had amassed numerous fish tanks in my tiny bedroom, much to the chagrin of my parents and their electric bill. By this time, the hobby had taken on new meaning. I was always trying to recreate the kinds of habitats in which my fish originated. Instead of puke-colored gravel and a bubbly treasure chest, I opted for soft, sandy bottoms and lush vegetation. Growing plants in an aquarium is no joke. Aquatic plants are a unique case in the botanical world. Like whales, the ancestors of most aquatic plants started on land. As such, the adaptations they needed for survival underwater made them a lot pickier than the pothos my mom was growing on the windowsill. Growing most aquatic plants proved too difficult for my angsty teenage brain and meager budget, so fish continued to command most of my attention. It would be a few more years before plants ever entered back into my life in any serious way. When the time came to go off to college, I had managed to make the connection between my aquarium hobby and the natural world. I decided to major in zoology and was seriously considering a career in fisheries biology, and for a few years at least, I really stuck to that plan. I was taking classes in subjects like invertebrate zoology, parasitology, and ichthyology, and largely enjoying myself in the process. Whereas I always felt like a nerd and outcast in high school, I was finally coming into my own in college. The people around me were also nerdy, and I no longer had to stifle my urge to geek out about the natural world. For the first time in my life, I was feeling like I was moving in a direction that made sense. Everything changed the day I took a field trip to a fishery. I never thought of myself as a squeamish person. Even the smell of roadkill was never overly offensive to me. That fishery cured me of such untested confidence. As soon as I stepped in the door, I was overwhelmed by the smell of dead fish. It was like walking into the seafood section of a supermarket after the power had been out for a week. I couldn't even finish the tour. There was no way I could work in such a place. And with that realization came the feeling that my career plans were crumpling in front of me. What was I going to do? After lots of thinking, I decided to change gears. I transferred to a different school and changed my major from zoology to ecology. Thanks to a lengthy conversation with a friend, I realized that my love of nature stemmed more from my understanding how ecosystems worked than from any individual organism. I wanted to learn how all life fits together, what drives evolution, and why we see animals in some places and not others. Ecology was the perfect subject for me because it is the study of the interactions among organisms. The deeper I dove into the science of ecology, the more I realized I was never going to be bored again. There was so much to learn about what ecologists already knew, and exponentially more to learn about aspects of the living world in which we were still a mystery. Plants still hadn't entered the equation yet, but ecology was broadening my horizons. I was thinking more and more about how energy moved through the environment. For instance, I learned the science behind food webs, which taught me why there are more plants than herbivores, and more herbivores than predators. Every time one organism eats another, some of the energy the prey contained is lost. As such, energy diminishes from plants to herbivore to predator. Ecology was turning on lights in my brain at the right place and at the right time in my life. It was also around this time that I landed the job that changed my life forever. It started in a class called Restoration Ecology. The professor was a kind man with a thick Canadian accent named Dr. Chris Larson. He taught the class seminar style, and it was largely geared toward grad students. I was one of only 3 undergrads in the class. Each week, we were assigned readings from a series of books. One of these was an incredible work by William K. Stevens titled Miracle Under the Oaks, The Revival of Nature in America. The book detailed the trials and tribulations of a grassroots prairie restoration effort in Chicago. Now, if you are a student of any of the biological sciences, one of the overarching themes is that humans are destroying habitats. It is so pervasive that it often seems like the only truism in biology. But here was this book celebrating a group of people who had decided that habitats didn't need to disappear forever. They were trying to put the pieces back together. The more I learned as the semester wore on, the more I was wooed by this idea of restoration. The thought of taking damaged areas of our planet and coaxing them back into functioning ecosystems was exhilarating. I was finally learning how the theoretical principles taught in class could be applied to something real and tangible, and all of it relied on a deep understanding of the interconnectedness of nature. As that semester was drawing to a close, I had another important realization. I needed a job. Part-time work at a pet store was not going to get me out of my parents' house. Luckily, my classmate Ashley was moving after graduation, and her bosses tasked her with finding a replacement. I inquired further, and she told me that her job was based in a limestone quarry and consisted of making sure the mining company was keeping up with environmental regulations. I fancied myself something of an environmental activist at this point in my life, so the idea of working for a mining company in environmental permitting was more than a little upsetting, to say the least. However, something in my head told me I needed to know more. As we walked out of class one afternoon, she gave me a brief rundown of what she did week to week. Most of it seemed pretty standard. Make sure the company isn't dumping too much sediment into local waterways. Set up seismographs to make sure blasts weren't damaging neighboring residential foundations, and hand out coupons for free car washes to neighbors who complained about all of the dust that landed on their cars. I wasn't really sold on the idea until she mentioned her side project, habitat restoration. I remember wondering why she hadn't led with that. She told me that the company was trying to improve its image a bit by engaging in habitat restoration projects on a few of their properties. This was quite a departure from most mining operations. Usually, mining companies do one of two things with their spent quarries. They either let them fill with water and become extremely deep ponds, or, if they are shallow enough, they backfill them, plant some grass, and sell them to housing developers. This company apparently had some unique properties that provided interesting opportunities for habitat restoration. One such property was an old sand and gravel quarry located in the southern tier of western New York. The massive deposit of sand and gravel was the result of the region's glacial past. Whereas most of the surrounding soils consisted of heavy clays and rocky glacial till, this chunk of land sat on top of a massive deposit of sand and gravel. As a result, it provided an interesting challenge for habitat restoration. Luckily, the mining company had gone outside its walls to ask for help from professional biologists, and a unique restoration plan was put into place. The project at the sand and gravel quarry involved restoring the habitat for a tiny butterfly called the Carner blue, Lycaetis melissa samulis. What this butterfly lacks in size, it makes up for in being extraordinarily beautiful. Its wings are covered in powdery blue scale that are rimmed in jet black. The bottom of each wing also sports a series of small orange crescents. You have to work to see one of these tiny butterflies in detail, but it makes the experience all the more exhilarating. Sadly, this beautiful little insect hasn't fared so well in our industrialized society. Populations of the Carner blue once ranged from coastal regions of New York and New Jersey all the way into parts of Minnesota. Today, it can only be found in a fraction of that range and is largely reduced to isolated populations. Like so many other species on our planet, its decline is largely due to habitat destruction. Habitat destruction comes in many forms, especially for species with complex ecological needs like the Carner blue butterfly. For starters, logging, farming, and housing development fracture the landscape, creating smaller and smaller patches of suitable habitat. Those small patches of habitat become increasingly susceptible to further degradation from the encroachment of invasive species, which crowd out native species. The habitats in which the Carner blue lives are also prone to fires. Although the massive wildfires occurring in places like California and Australia are horrifically destructive to people and nature alike, many ecosystems on our planet require fire to persist. The sad part is humans generally look at fire as a negative force on the landscape that must be stopped. When Europeans arrived at this continent, they set to work making sure that fires stopped happening. Historically, fires would have burned through Carner blue habitats every few years. In doing so, they cleared the ground of a lot of woody debris and leaves. This meant that no single fire would ever have enough fuel to get out of control. Fires also kill off vegetation like shrubs and small trees that aren't adapted to cope with heat. This opens up the habitat, keeping trees widely spaced and allowing more light to reach the soil, which in turn allows plants that can handle fire to multiply in abundance. All these processes once provided ample habitat for species like the Carner blue butterfly. Today, thanks to a lack of fire, much of the Carner blue's remaining habitats have been choked with invasive plants and shrubs. Encroachment of invasive plants has changed the entire dynamic of the ecosystem and, worst of all, has pushed out a species that is particularly important for the Carner blue butterfly, perennial blue lupin, Lupinus perennis. Blue lupin is a spectacular plant. At maturity, it could stand upwards of 2 feet, 0.6 meters tall, and produces lovely palmately compound leaves that look like hairy green fans. When lupin goes into reproductive mode, a spike emerges from the center of the plant. This spike is covered from top to bottom with violet-blue pea-like flowers that attract insects from far and wide. The whole spectacle is truly a sight to behold. Most insects on our planet are specialists. They have evolved to utilize only a handful or even a single species for feeding and breeding. The Carner blue butterfly is one such species. Its caterpillars can only eat the leaves of blue lupin. No other plant will do. Losing blue lupin on the landscape means losing Carner blue butterflies. This concept was at the core of the restoration efforts in the sand and gravel pit. Ashley didn't have to twist my arm to convince me to apply for the job. I applied and was hired a few weeks later. I was excited to finally get my hands dirty. The permitting aspects of the job were pretty straightforward and not all that exciting, so I poured most of my energy into learning about Carner blue butterfly habitat restoration. I learned that for the project to be successful, we needed to ensure that the property could support Carner blue caterpillars. The caterpillars themselves are kind of cute when you see them close up. They are small, chubby, and emerald green. They don't possess much in the way of defenses either. They don't grow stinging hairs. They don't sequester poisons in their skin, nor do they secrete foul-smelling odors. If you were a hungry bird, they would make a nice snack. However, they aren't completely defenseless. Far from it, in fact. One of the coolest aspects of their ecology is that Carner blue caterpillars have teamed up with a few species of ant. Anyone who has ever disturbed an anthill quickly learns how vicious ants can be. They aggressively defend their homes, as well as reliable sources of food. Through evolutionary time, the Carner blue butterfly, and many of its close relatives, have tapped into the ant's need to protect reliable food sources, striking up a symbiotic relationship. If you look near the rear end of a Carner blue caterpillar, you will find a tiny gland. That gland secretes a special liquid that is chock full of sugars, amino acids, and water. Some ants have figured out that, with a little prodding, they can coax the caterpillar to secrete that fluid. Ants learn to associate each caterpillar with a reliable source of food, and teams of ants begin tending caterpillars as they feed. Anything that may threaten the caterpillar, be it a predator, insect, spider, or bird, will have to contend with a small army of ants. The ants are effective, too. Caterpillars tended by ants are 67% more likely to survive than caterpillars that aren't. This relationship may even go beyond defense. Ants live in high densities and are very susceptible to attacks from fungi and other microbes. To protect themselves, ants too have a tiny gland on their body called metapleural gland, which secretes antimicrobial fluids that the ants scrub all over their bodies. It turns out that some of this fluid is also transferred to the caterpillars as the ants dote on them. As such, ants may also help Carner blue caterpillars fight disease. It is funny to me how most nature programs focus on animals from places far away. They act as if the only interesting things in nature happen deep in the jungles or out on the African savanna. What I was learning was that so many incredible ecological interactions were happening right in my own backyard. I found that my environmental interests were no longer drifting away from home, but instead were being consumed by things going on in my own neck of the woods. Learning about these fascinating ecological relationships made me fall head over heels for this project. I wanted to do everything in my power to make sure that the restoration efforts would succeed. However, it wasn't long before an even weirder thought started creeping into my mind. I was beginning to understand that none of these amazing relationships would be possible if it were not for blue lupin. These plants were the hub for all these remarkable interactions. If I wanted to help this project to succeed, I had to keep that in mind. When it finally came time to visit the site, I was blown away by the progress that had already been made. I rolled into the parking lot one early spring morning in 2008 and was greeted by a tall, bearded man. His name was Mike Myers, but he bore absolutely no resemblance to the murderous villain of the Halloween franchise. Instead, he was soft-spoken and gentle, with an inclination toward native pollinators. We made our introductions, and he instantly launched into the background of the site. It turns out the Carner blue butterfly project was largely his brainchild. Whereas the quarry supervisors were happy to provide the site and the financial backing for the restoration efforts, Mike was the person who realized the true potential of this now defunct sand and gravel pit. As he talked, I could tell he was growing more and more excited about the project, so we moved on from the parking lot and began surveying the restoration site. We hiked up and over one of the larger berms and were greeted with an amazing vista. Down below was a small pond that was a leftover from the active quarry days. Much of it was lined in swaying cattails, genus Typha, and I could hear the red-winged blackbirds calling for mates. Down at my feet, wild strawberries, Fragaria virginiana, carpeted the hillside. Mike bent down and picked a few, handed them to me, smiled, and pointed across the pond. On the berm opposite us was a wall of color. 2 years earlier, that berm was seeded with a native wildflower mix full of species that didn't mind a bit of drought. Besides lacking nutrients, sandy soils don't retain water for very long. Without spongy organic material like decaying leaves and wood, water drains away nearly as fast as it falls. Anything growing in sand must be okay with its roots drying out. Mike proceeded to tell me that not only had the berm proven that seed sowing could work, it also had won them a pollinator habitat award, and they were very excited to expand the application. As he waxed poetic about the process, I began noticing signs of life all around me. Bees and butterflies were flitting around, visiting what flowers were in bloom. On the bare ground around us, I could make out the tracks of either a fox or a coyote that obviously enjoyed the vantage point the elevated terrain provided. We walked down to the edge of the pond, and it was wriggling with toad tadpoles. The idealistic environmentalist in me was dumbfounded. Open-pit mining is one of the most destructive practices that has ever been invented. To gain access to whatever geological layer they are interested in, mining companies first strip away all the topsoil covering it. With the topsoil goes all the life that it once sustained. Plants, microbes, insects, everything. Whatever life once called this place home had been completely removed. Yet here we were, staring at a preponderance of life that rivaled most of the surrounding landscape. Don't get me wrong, I am by no means excusing the destruction of wild places. I firmly believe that if our species has any hope, we need to protect wild spaces at all costs. However, this quarry was first-hand proof that humans could also put at least some of the pieces of our damaged planet back together. The dominant vegetation growing around us largely consisted of strange-looking grasses. These were growing in dense clumps with open spaces in between. These open spaces boasted beautiful wildflowers whose identities were also a complete mystery. Being the inquisitive observer, I asked Mike why this place looked so strange. He proceeded to tell me that, thanks to the drought-prone nature of the sandy soils, they couldn't settle with using more familiar, cool-season grasses. Instead, they opted to establish a meadow comprised of warm-season grasses, the likes of which one doesn't frequently encounter in cooler, wetter regions like western New York. One was a tall, lanky species with blue-green leaves and golden-brown seed heads called Indian grass, Sorghastrum nutans, and the other was a small, scrappy-looking plant with hints of blue and red throughout, called little bluestem, Schizocarium scoparium. Both species were completely new to me, and I was feeling very stupid at that point. Here I was, freshly hired to undertake a massive part of this restoration project, and I had never come across the terms cool season or warm season grasses before. Mike laughed and kindly provided me a quick lesson on grass biology. Plants are constantly having to balance the exchange of CO2 and oxygen with the loss of water. They do so using tiny pores on their leaves and stems, called stomata. When temperatures rise, causing water to evaporate from the stomata at a higher rate, plants can close those spores to avoid dehydrating. However, in doing so, they also cut off the supply of CO2 coming into the leaf, while at the same time allowing oxygen concentrations to build. The buildup of oxygen becomes a serious problem for plants, thanks to the activities of a vitally important enzyme called rubisco. Rubisco's job is to take carbon molecules from CO2 and help build sugars with them. Not only is rubisco the most abundant enzyme on our planet, its role in photosynthesis also makes it one of the most important. However, Rubisco can be surprisingly bad at its job. Nearly half of the time, Rubisco grabs oxygen instead of CO2. This is bad news for plants because
Sample complete. Ready to continue?